Okay, so today we have the lumbar vertebra. These are five in number. The lumbar vertebra, lumbar 1 to 4. These are typical lumbar vertebra, and fifth lumbar vertebra, it is atypical lumbar vertebra. So a few questions that we'll need to understand as we speak about the lumbar vertebra is that how is it different than thoracic vertebra and cervical vertebra. It's different than thoracic vertebra and cervical vertebra. We'll understand the difference between thoracic vertebra and cervical vertebra. If one point is asked, is different from thoracic vertebra, it's because it does not have a costal facet. Costal facet নাই, transverse process it does not have a costal facet. And বডিতে এই যে বডির দুই সাইডে আমরা কোস্টাল ফ্যাসেট দেখি, ট্রান্সভার্স প্রসেসে কোস্টাল ফ্যাসেট দেখি, কোস্টাল ফ্যাসেটগুলো নাই। Then from cervical vertebra, it's foramen transverse area that's not present here. Those are the differences. Another difference is that the vertebral foramen, it's triangular in shape, whereas the shapes are different in thoracic and cervical vertebra. Also, the vertebral foramen, it's different than it's vertebral foramen, it's smaller than cervical vertebra, but it's larger than thoracic vertebra. It's because why is it larger than thoracic vertebra? It's because it needs to accommodate the lumbosacral enlargement of the spinal cord. There are two enlargements, cervical and lumbosacral. This accommodates the lumbar vertebra, it accommodates the lumbosacral enlargement of the spinal cord. Now let's come to the bodies, the presenting parts. Obviously it is a vertebra, so it has a body and an arch and the vertebral foramen. The body, it's large and reniform in shape. The body is large and reniform in shape. Reniform means kidney shaped. Its anterior posterior diameter is smaller than the transverse diameter. See, this is the anterior posterior diameter, this is the transverse diameter. The anterior posterior diameter is smaller than the transverse diameter. And what are the other aspects? Okay, we talked about the vertebral foramen. We'll talk about it later again with its contents. Now the arch, it has pedicles and lamina. The pedicles are short and thick and very strong. They present is superior intervertebral notch and inferior intervertebral notch. Superior intervertebral notch, it's shallow, and inferior intervertebral notch, it's very deep. Okay, it's very deep and it's very shallow. From the junction of pedicle and lamina, we have we have the superior articular processes, inferior articular processes. The superior articular processes, they are directed posteriorly and medially. They're directed posteriorly and medially. Then we have the superior articular facet, which is concave. Okay, it is directed posterior medially. And the inferior articular process, they have inferior articular facets. These are directed forwards and laterally. This will be an important marking point, the superior and inferior articular processes. These will be an important marking points in differentiating between the typical and atypical lumbar vertebra. Okay, now from the junction of pedicle and lamina, we also have the transverse processes. The transverse processes, these are thin and tapering, and these originate from the costal element, and they represent the ribs of the vertebra, ribs of the thorax. They originate from the costal element. Okay, now what arises from the transverse element? What's the true transverse process here? There's an accessory process right here. Okay, accessory process right here in the inferior aspect of the transverse process, posterior inferiorly. It has accessory process. This arises from the transverse element of the vertebra, is the true transverse process. Okay, and from the from the superior articular process, posterior aspect, it has another process called mammillary process. Okay, now at the junction of the two lamina we have the spinous process. The spinous process, it is short and stout and directed horizontally. Okay, it is directed horizontally and it is quadrilateral in shape. It is quadrilateral in shape. Quadrilateral in shape. Okay. All right. Now let's talk about the attachments. We have the attachment of in the body. We have anteriorly we have the anterior longitudinal ligament. Posteriorly we have the posterior longitudinal ligament, and right a bit laterally to the anterior longitudinal ligament we have the attachment of the crus of the diaphragm. For the we know there are two crus of the diaphragm, right crus and left crus, and the right crus is longer. That's why in the upper three vertebra on the right side we'll have the attachment of the right crus of the diaphragm, but the left crus is shorter, so we'll have the attachment of the left crus of the diaphragm only for the upper two lumbar vertebra. Only for the upper two lumbar vertebra. Now after the crushes of crura of the diaphragm, then we have the attachment of the psoas fascia and then psoas major muscle. Now psoas major muscle, it is divided, it is separated from the quadratus lumborum muscle by the anterior layer of thoracolumbar fascia. The anterior layer of thoracolumbar fascia, it is attached at a vertical ridge. There is a vertical ridge here in the anterior surface of the transverse process. Here the anterior layer of thoracolumbar fascia, it is attached. Okay, so it separates the anterior layer of it separates the psoas major muscle and the quadratus lumborum muscle. At the tip of the transverse process we have the attachment of the medial layer of thoracolumbar fascia. Now the medial layer of thoracolumbar fascia and anterior layer of thoracolumbar fascia, these enclose the quadratus lumborum. These enclose the quadratus lumborum, and the posterior layer of thoracolumbar fascia, it is attached at the spinous process. At the spinous process. So the posterior layer of thoracolumbar fascia and the middle layer of thoracolumbar fascia, these enclose two muscles. That's multifidus and erector spinae. Multifidus and erector spinae. Now getting back to the transverse process. The transverse process, at the tip of the transverse process, we already talked about the attachment of the middle part of the thoracolumbar fascia. At the middle part of the thoracolumbar fascia, then we have the attachments of unique attachments. For the tip of the first lumbar vertebra, tip of the transverse process of the first lumbar vertebra, we have the attachment of the medial and lateral arcuate ligaments. Medial and lateral arcuate ligaments. Now after the attachment of the medial and lateral arcuate ligament, at the posterior surface of the transverse process, we have the origin of the longissimus thoracis. Okay, longissimus thoracis is part of the erector spinae muscle. It is originated at the posterior surface of the transverse process, and the accessory process, it provides attachment to the medial intertransverse muscle, and at the mammillary process we also have the attachment of the medial intertransverse muscle, and we have another attachment at the mammillary process, that is the multifidus muscle. Now at the back, in the spinous process, we have the attachments of supraspinous ligament, infraspinous ligament, erector spinae muscle, multifidus, and posterior layer of thoracolumbar fascia. We have the attachment of the posterior layer of thoracolumbar fascia. Those are mostly the attachments. Okay, and there is attachment of ligamentum flava in the lamina, which creates the joint between lamina to lamina, transverse process. We have another ligament, but the joint between lamina to lamina, syndesmosis type of fibrous joint, it's formed by the ligamentum flava. Okay, now let's come to the intervertebral foramen, the vertebral foramen. Let's come to the vertebral foramen. The vertebral foramen, it transmits the spinal cord. Simple as that, we know that, right? the vertebral foramen. Now, here is the thing: the spinal cord, it ends at the lower border of lumbar 1 vertebra. Spinal cord এখানে শেষ। এখন spinal cord এখানে শেষ হয়ে গেল, what happens after that? We have now the spinal cord, it has three layers, we can say: dura mater, arachnoid matter, and pia mater. Okay, between the dura mater and arachnoid matter, we have this subarachnoid space, which contains the cerebrospinal fluid. Okay, now at the lower border of lumbar 1 vertebra, we have the tapering end of the spinal cord, which is called the conus medullaris. So for the lumbar 1 vertebra, if we are asked the content, it is conus medullaris with meninges. Now what happens after that? We have the continuation of the spinal cord, which is known as the cauda equina. Cauda equina. What is cauda equina? Cauda equina, it's a collection of the spinal nerves. Spinal cord ওখানে lower border of lumbar 1 শেষ। lumbar 1 শেষ হওয়ার পরে it has a continuation later on as spinal nerves. This collection of spinal nerves, it looks like a horse tail. That's why it's named as cauda equina. So for the rest of the lumbar vertebra, lumbar 2, 3, 4, 5, the content is cauda equina with meninges, and we have phylum terminalis. Phylum terminalis, it is the continuation of the pia sheath. Now since we have the cauda equina and there is the subarachnoid space, which is which consists of the cerebrospinal fluid. Now here comes the aspect of the lumbar puncture. Lumbar puncture we do for the CSF collection, for culture. CSF collect করে, আমরা cerebrospinal fluid collect করে, we do culture to do a lot of laboratory tests to identify diseases, diagnose diseases. Now if we want to do lumbar puncture, we need to avoid the damage of the spinal cord. So the spinal cord it has ended at the lower border of lumbar 1. So if we can insert the needle between any other space where the cerebrospinal fluid is there but the spinal cord is not there, that's going to be an important key aspect, because we will be able to avoid the injury of the spinal cord. That's why we do lumbar puncture between lumbar 2 and lumbar 3. Why lumbar 2 and lumbar 3? It's because subarachnoid space is here, cerebrospinal fluid is here. Cerebrospinal fluid, it terminates at the level of second sacral vertebra, sacral 2. Okay, so this subarachnoid space is there, so we do lumbar puncture between lumbar 2 and 3. Why lumbar 2 and 3? Because lumbar 2 and 3, between the lumbar 2 and 3, we have the minimum overlapping of the lamina, so needle insert করতে easy হবে. Okay, we already talked about we're done with the vertebral foramen. Now let's come to the intervertebral foramen. What does the intervertebral foramen transmit? The intervertebral foramen, it transmits the spinal nerves. How many pair of spinal nerves? 31 pair of spinal nerves. Spinal nerves are mixed nerves. Why is it called a mixed nerve? Because spinal nerve have two roots, ventral root and dorsal root. Ventral root, it is a motor, and the dorsal root is sensory. How do you know it's the dorsal root? How do you identify the dorsal root? The dorsal root, it has ganglia. What is ganglia? It is the collection of cell bodies of a neuron outside the central nervous system. Okay, that's pretty much it about the spinal nerves. Now the spinal nerves, we are done with intervertebral foramen. Let's talk about the intervertebral disc and the joints of the vertebra. Now the joints of the vertebra and the intervertebral disc. The intervertebral disc, intervenes between the two bodies of the two vertebra, and it is a fibrocartilage, white fibrocartilage, which consists of two parts: central nucleus pulposus and peripheral annulus fibrosus. It's a nucleus pulposus, it's a remnant of notochord. It's a remnant of notochord. Then about the joints, since it has white fibrocartilage in between the two bodies, it is a secondary cartilaginous type of joint. We do have fibrous syndesmosis type of fibrous joint between transverse process, then spinous process to spinous process, lamina to lamina. This is another. Then we have the joint between superior and inferior articular facets, which is plain zygapophyseal type of plain synovial joint. Okay, and the joint between fifth lumbar vertebra and sacrum, which is also secondary cartilaginous joint. Now, we did not talk about the fifth lumbar vertebra. So the fifth lumbar vertebra, it consists. Why is it different? The body is massive. You can literally see this is the fifth lumbar vertebra. The body is huge. Okay, সবগুলোর বড় বাপ এটা, ঠিক আছে? Body is huge. The body is huge, and the pedicle, it's almost fused, and the transverse process, it's pyramidal. It's not tapering anymore. It's pyramidal. Okay, the transverse process, it's not tapering anymore. It's pyramidal, and its base, the base of the transverse process is almost fused with it. The base of the transverse process is almost fused with the pedicle. Okay. This transverse process, it's almost fused. What else do we have here? What are the difference? How do we identify the body is massive? Oh, the key difference, sorry, forgot about that. It's because it's that usually the distance between superior articular facets is larger than the distance between inferior articular processes or facets, but in case of the fifth lumbar vertebra, the distance is almost equal, and sometimes it's less. The inferior articular, the distance between inferior articular processes is sometimes more than the distance between superior articular processes. And the superior articular facets, these are more posteriorly than medially. These are located more posteriorly than medially, and the inferior articular facets, these are located more laterally than forward. These are the aspects. Oh, and the tip of the spinous process, it's a bit downturned. Okay, that's pretty much it for the lumbar vertebra. Oh, another aspect is sacralization, lumbarization. What is sacralization? Sacralization is complete or incomplete fusion of the fifth lumbar vertebra with the sacrum. If this occurs, what happens is that the fifth lumbar spine, it gets compressed. That's sacralization, and lumbarization is the opposite. Okay, that's pretty much it. We talked about the vertebra, its morphological type, it's irregular bone, and this body, it's modified long bone. Why is it a modified long bone? It's because it transmits body weight. Okay, all right. Another aspect here is we have, yeah, I think we're pretty much done here. Yep, pretty much done. Thank you.